Hi students, in this module we are going to discuss about the different types of functions, and in our previous modules we discussed what is a definition of a function. You know very well that function is an operation or a rule where we are associating the elements of set A and set B. Set A is always taken as the domain, and whereas set B is always taken as the codomain, where all these elements which are present in this set B are having the association with the set A. Okay, if all the elements of set B are having the relation with the elements of set A, then all those elements in the set is called as the range, whereas the elements which are not having any kind of relationship with the elements of set A will not be called as range, they will be called only as the codomain. So these all things we discussed in our previous module. Now we are going to discuss the different types of functions, and the first one is even function and odd function. So what is even function and odd function? Before that, we should know that we represent the image of any element. Suppose element is taken as x and its image is always taken as f of x. So let us take one function f of x equal to some x square. F of x is equal to x square. Now we are going to test whether it is an even function or odd function. Now if suppose we take in place of x minus x, what may happen to this function? So this x will be changed as minus x, so whole square as it is. So it was f of x, when there was x, it was x square, when it is taken as minus x, it is changed to minus x whole square, and you know very well that this square will remove the minus. So it will again become x square. Now compare these two. F of x is x square, f of minus x is also x square. So what we understand is f of x and f of minus x both are equal in this case. These two are equal to x square. So say this type of function with the name even function. So what is even function? If f of x and f of minus x are equal, then that function can be called as an even function. Now let us take another example. F of x is equal to sin x. Now we take f of minus x. What may happen? Sin of minus x. You know very well that sin will vomit that minus outside. So it will be minus sin x. Now check it. Here f of x is sin x, f of minus x is minus sin x. These two values are not same. What we have understood is f of minus x is nothing but minus the same minus. What is sin x? That is f of x. So f of minus x is equal to minus f of x. So such type of function will be called as an odd function. Compare these two. In even function, f of minus x and f of x both are equal, whereas in odd function f of minus x will be equal to minus of f of x. Now let us take another example also. Now let us take another function f of x equal to cos x. We are going to test whether it is an even function or odd function. So as per the rule, we should take in place of x minus x, so it will become cos of minus x. You know very well cos will swallow the negative symbol, so it will become cos x. Sin will vomit the minus, whereas cos will swallow the minus. That you have to remember. Now from this what we understand is f of x and f of minus x are not at all changing, they are equal. So this function is an even function. So very simple concept. If f of x equal to f of minus x, then the function is an even function. If f of minus x is minus into f of x, that minus of f of x, then we can say that as an odd function. Now let us discuss other models. Now let us take the next type of function, that is identity function. So in our previous modules we discussed about the identity relation. There itself we discussed that f of x is equal to x. There I told you that both the elements, that means in the ordered pair we were getting all elements such as x comma x. Here f of x equal to x, that means the image and pre-image, both the values are same. Let us take for example, here it is A domain, B codomain. Here the elements are 1, 2, 3. Here also we have the elements 1, 2, 3. If 1 has the image 1, 2 has the image 2, 3 has the image 3, then what we understand is f of 1 is equal to 1, f of 2 is equal to 2, f of 3 is equal to 3, and so on. So if you take f of x, there also will be x. Such function is called as an identity function. So what is an identity function? In identity function, the image and pre-image are same. Now we will discuss about constant function. Okay, now let us take the constant function. Constant function is a many to one function. Now let us take A, say this is B. 1, 2, 3, 4 are the elements of set A. Here we have elements 4, 5, 6. Suppose this 1 has relation with 5, 2 has relation with 5, 3 has relation with 5, 4 has relation with 5. Check it. This is the function, isn't it? So what we have, f of 1 is equal to 5, f of 2 is equal to 5, f of 3 is equal to 5, f of 4 also 5. So all these elements, that means all these pre-images are having the same images. Here all the pre-images are having only one single image. What is the image? F of 1 is equal to 5, f of 2 is also 5, f of 3 is also 5, f of 4 is also 5. So this type of function is called as a constant function. So in general we will write this as f of x equal to some constant k. Whatever the value you take for x, that means 1, 2, 3, 4, 5, etc, 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 etc. From the domain, you will have a single element as the image. So f of x equal to k. If such structure is found in the function, then we call the function with the name constant function. So I repeat it. The constant function is a many to one function where the pre-images are having a single element as the image. Now we will discuss the next model. Now let us discuss about the other two different types of functions. They are implicit functions and explicit functions. In general, we will be seeing such equations: y is equal to 2x plus 3 or y is equal to 7x square plus 4x plus 5. Such type of functions are called as explicit functions. Explicit functions. Remember, here x and y are the two variables. We call x with the name independent variable, whereas y is called as dependent variable. So the value of y is depending on the value of x. So if you are able to separate the dependent variable and independent variable on either sides with the equal symbol, then we can call such function with the name explicit functions. So in the explicit functions, always the function will be like a y is equal to f of x. Y is always expressed in terms of x. Suppose, let us take the same, the first one, that is y is equal to 2x plus 3, that I take, by taking this y to the right hand side, we will get another new equation, say 2x plus 3 minus y is equal to 0. What has happened? Here both dependent and independent variables are mixed together. If you are writing the functions like f of x comma y is equal to 0, such type of functions can be called as implicit functions. So, in the implicit functions, what may happen? In implicit functions, what may happen? Here, both the dependent and independent variable are present in the same side. In explicit functions, dependent variables are at one side and independent variables are at the other side. Okay, now we are going to the last model, that is homogeneous functions. Homogeneous function means the powers or the degree of each and every term in the given expression or given function will be same. For example, if you write x square plus xy plus y square, check in all the terms. Here x square is the first term, so the highest power is 2. Here xy means the power of x is 1, power of y is 1, so total power in this xy is 2. Y square, here also the highest power is 2. So in each and every term of the given function are same values. Suppose we take x cube plus x square y plus xy square plus y cube. Check here. Here the highest power is 3. In each term you can see the power is maintained the same. Such type of functions are called as homogeneous functions. So these type of functions are called as homogeneous function. Okay. In this module we discussed the important types of functions like even function and odd function, identity function, constant function, implicit function, explicit function and homogeneous function. So in our next module we will discuss the other important types and we will discuss some important problems also. Thank you.